We usually think about borders as like lines on a map, things politicians decide. But what if there's a boundary, completely invisible, that's shaped animal life for millions of years?
Exactly.
Yeah.
A line where just crossing a few miles puts you in a totally different biological world.
We are definitely doing a deep dive into the Wallace Line today.
We are. And it's this profound natural split, really highlighted by Alfred Russel Wallace back in the 19th century. He was exploring the East Indies, Indonesia, mostly today.
Right, and we're drawing a lot from the Wikipedia page on the Wallace Line for this. It's a great starting point.
It really lays it all out, the whole fascinating story.
And the big question, the thing that got Wallace thinking and still gets us thinking, is just why? Why such massive differences in animals between islands that are, practically neighbors?
Yeah, it's a real puzzle, a biological mystery that tells us so much about evolution, about how life spreads. Okay, so how did Wallace even land on this? What were the first hints?
Well, it seems like the clues were kind of scattered around before him.
That's right. The Wikipedia source mentions Pigafetta way back in 1521 with Magellan. He apparently noted differences traveling between the Philippines and the Maluku Islands.
Which we now know are on opposite sides of this line.
Exactly. Then much later, 1845, you have G.W. Earle, an English navigator. He saw that Western islands, Sumatra, Java, places on the Sunda Shelf, they had animals like mainland Asia. Shallow seas connected them, you see.
Okay, so they were linked to Asia when sea levels were lower.
But Earle contrasted that with eastern islands, like New Guinea, which seemed, linked more to Australia. They had marsupials. That was the big tell.
Marsupials, right. So people were noticing these patterns, these sort of zoological zones, but Wallace put it together.
He did. After years traveling and collecting out there, he published this really important paper in 1859. And in it, there was a drawing. A line.
The line.
Pretty much. His big observation was this sharp divide, especially with land mammals and birds, Asian types to the west, and a mix including Australian types marsupials again to the east. He drew his line east of Borneo and Java.
And he suggested the eastern islands were connected to some kind of ancient Australian continent.
Yeah, or Australian or Pacific continent was his phrasing. But here's the key thing. He wasn't just, collecting stamps. He wanted to understand why.
Right. It wasn't just about drawing lines. He was after the deeper story.
Totally. His main goal was figuring out the geology, the history, the colonization events that caused these patterns. It fit directly into his ideas about evolution and biogeography, how life gets distributed.
So his work there was really crucial evidence for evolutionary theory as it was developing.
Absolutely critical. Happening right alongside Darwin's work, providing that real-world geographical evidence. The source does note he had some trouble figuring out where the Philippines fit in exactly. Plate tectonics wasn't understood then, which made it trickier.
Ah, okay. So the Philippines were a bit of an anomaly in his initial view.
They sort of were. His 1859 line didn't actually swing around to include them. It was Thomas Henry Huxley, Darwin's bulldog.
Oh, yeah, Huxley.
Well, in 1868, Huxley looked specifically at certain bird groups, and he proposed placing the line west of the Philippines. And he's actually the one who called it Wallace's Line.
Huh. So the name came from Huxley, and the exact placement west of the Philippines wasn't Wallace's original idea for that bit.
Kind of ironic, isn't it? But it's stuck. So, okay, let's get to the physical reality. What makes this line? What's the geology?
Yeah, what's underneath it all?
Deep water. That's a simple answer. The Wallace Line follows this really deep oceanic channel separating two continental shelves. To the west, you've got the Sunda Shelf.
Which connects to mainland Asia?
Right. Islands like Borneo, Bali, Java, Sumatra, they're sitting on that shelf. When sea levels dropped during ice ages, they were basically part of Asia.
Okay. And to the east.
That's the whole shelf. It connects Australia and New Guinea and their nearby islands. Same deal, lower sea levels meant one big landmass over there.
So two giant land masses during ice ages, but crucially separated.
Precisely. And the water between them, in that channel the Wallace Line traces, is deep. Even when sea levels were, what the source says, 120 meters lower, that channel remained water, a significant barrier.
How long?
Get this. Over 50 million years. For 50 million years, there's been this deep water gap preventing easy land migration between the two zones.
50 million years. Wow. Okay, that explains a lot. That's enough time for life to go in very different directions.
It really is. That long isolation is why the plants and animals evolved so differently on each side. The source points to the Lombok Strait between Bali and Lombok.
Yeah, I saw that, only 35 kilometers wide.
Just 35 kilometers.
Yeah.
But the animal life is drastically different. Bali is Asian fauna. Lombok starts showing the Australasian influence. All because that strait, while narrow, is part of that deep water channel.
It's like an invisible wall for land animals.
Amazing. So, okay, let's talk specifics. What kinds of animals are we talking about on each side? Give us the highlights. Right, the fun part. West of the line, the Asian side, think placental mammals. That's us, basically mammals with a placenta.
Yeah.
So apes, monkeys, tigers, elephants, rhinos, the classic Southeast Asian megafauna, and smaller mammals too.
Okay, the familiar Asian zoo animals, so to speak.
Pretty much. Now, cross that line eastward towards Australia and New Guinea, and boom, it's marsupial territory.
Kangaroos, koalas.
Exactly. Possums, wallabies, wombats. The whole pouched mammal crew dominates. The source mentions some native rodents got across later, probably rafting or something, but the dominant mammals are marsupials. And you also get monotremes, the egg layers, like echidna.
It's like two different planets, biologically, right next door. Placentals versus marsupial.
It's one of the starkest examples anywhere on Earth. And it's not just mammals. Birds, too.
Ah, right. Birds often respect the line, too.
Yeah, many bird species just don't like crossing open ocean, even relatively short stretches. So the line is a major barrier for their distribution as well.
Interesting. What about plants? Do they follow the line?
It's less strictly. The Wikipedia page notes that plants have different ways of getting around wind dispersal, seeds floating on water, carried by birds, maybe. So they can sometimes cross barriers that stop animals.
But there are still some patterns.
Oh, yeah. A great example is eucalyptus. Gum trees.
Very Australian.
Exactly. Almost entirely found east of the line, in the Australasian zone. There's one exception, Eucalyptus teglupta, the rainbow eucalyptus, which made it to the Philippines. But generally, eucalypts stay east.
Wow. So the line holds pretty well across different life forms, even if plants are a bit more flexible. Now, Wallace wasn't the only one trying to map this out, was he? You mentioned Huxley. Were there others?
Yeah, absolutely. This transition zone, it's complicated, right? It's not always a razor-sharp line for every single species. So after Wallace, other scientists proposed variations.
Like refining the boundaries?
Sort of. The source lists a few. Slater's line, Leidecker's line, Weber's line, which is also called Pelsnier's faunal balance, and then Mayer's faunal balance later on.
What were they trying to do differently?
Often they focused on different animal groups or tried to define more of a transition zone where the fauna is mixed rather than just a single line. Weber's line, for instance, tried to find the point where Asian and Australian fauna were roughly balanced in number.
Okay, so it became clear it was maybe more of a gradient in some ways.
For some groups, yes.
Yeah.
But what's really striking, and the source emphasizes this, is that modern research using, huge biodiversity data sets, genetic analysis, fancy mapping tools.
All the modern tech.
Right. It largely confirms the fundamental division that Wallace and the others identified way back in the 19th century. The basic pattern holds up remarkably well.
That's incredible. It really speaks to how good their observations were, even without the tools we have now.
It really does. And it's still relevant. The Wikipedia page even mentions a recent study, just from 2020, about Christmas Island's fauna.
Oh, yeah. What about it?
Well, based on some extinctions, some ancestral mammals and amphibians disappearing from the Lombok Strait area, this study argues maybe we should reconsider the line's placement there and put Christmas Island firmly on the Australasian side.
So we're still fine-tuning our understanding based on new evidence.
Exactly. It's not just some historical curiosity. It's an active area of research. Our picture keeps getting refined.
So wrapping this up then, the Wallace Line isn't just a line on an old map. It's a really profound, real boundary in nature.
It absolutely is. A testament to how deep geological history, millions of years of separation, shapes life. Wallace's insight, based on careful observation, is still fundamental to how we understand why animals live where they do.
It really makes you think, doesn't it, about how the world looks static to us day to day. But these immense, slow processes have created the incredible diversity we see, and it leaves you wondering.
What else is out there?
Yeah. If this dramatic line exists here because of these clear geological barriers, what other, maybe more subtle geographic features around the world might have acted like invisible lines, shaping life in ways we haven't fully appreciated yet? What other hidden boundaries are waiting to be understood?
That's definitely something to ponder.